Let n belongs to set of natural number and let Gn define as this integral. Which of the following statements are true? Jn is rational for all n greater than equal to 2. Jn is irrational for all n greater than equal to 2. Jn is rational for n is 7. Means rational irrational about the Gn. So which number, or when we say a number is rational or irrational, if number contains square root of prime numbers, then we say this is a irrational number. If decimal expansion we anyhow we can find, then if decimal expansion having some terms, some numbers repeating, this is repeating but not ending, then this is comes in, or we can write this is a rational form PYQ where Q not equal to 0. And if decimal expansion is after a certain digits end, like 0.2753, if after some time decimal expansion end, then this is also comes in a rational format. But decimal expansion which is neither repeating or not ending, like 2375, means 22 by 7, you can understand this is a decimal expansion never end and digit also never repeating. So these types of decimal expansions comes in irrational number. So this is basic idea about rational and irrational number. If anyone which is coming in this integral, then we can easily tell about the Jn is rational or irrational on the basis of this. As Jn is given as integral from 0 to pi by 2 cos raised to the power nx dx. We have studied this reduction formula in our college level. So you can break this as 0 to pi by 2 cos square x and cos n minus 2x dx. But I am proceeding from this one 0 to pi by 2 cos x and cos n minus 1x dx. You can proceed from this, and in place of cos square you can replace 1 minus sin square x. So Jn, I call this is a first function and this is second function, and integrate by parts. So first function is same as an integral of second one. So cos raised to the power n minus 1 x, and this is sin x. This is my first function, minus of derivative of first function n minus 1 cos n minus 2 x, and derivative of cos x is my sin x, sin x, and integral of second function is again sin x. This is dx, and limit is from 0 to pi by 2. So Jn can be written as this first term is same as minus, because the derivative we have to take derivative of cos x, so minus sin x. I thought this is integral, so minus minus turns to positive, and we can take n minus 1 outside from this integral. So write cos n minus 2 and sin square x dx, and limit is 0 to pi by 2. So this term is again same, and this is n minus 1, and we can write cos n minus 1, this is integral sign, and write 1 minus cos square x dx, and limit is 0 to pi by 2. Left hand side is same as Jn, so Jn can be written as first term, this is first term, plus n minus 1, and this is integral, so you can write This is integral from cos n minus 1 x dx minus of cos, this is minus 2, so this is n minus 2, so cos raised to the power nx dx, and limit is from 0 to pi by 2. So this is nothing but jn minus 2 if we can reduce n by 2, and this is jn. So this is jn and this is jn, so you can take in same side, so take jn as a common, so 1 plus n minus 1, because this is the coefficient or part of this one jn, equal to, and this what was this expression? This expression was cos raised to the power n minus 1 x sin x. Cos raised to the power n minus 1 x sin x, and limit is from 0 to pi by 2, and we obtained n minus 1 j n minus 2. So after applying limit in this expression, when we put upper limit, so cos will goes to 0, and when we put in lower limit, so sin x 0, so finally this term goes to 0. So left term is jn, and 1 minus 1, this is cancel out, we obtained n minus 1 divided by n jn minus 2. So finally we obtained this term. This means we have reduction formula for Gn. Gn can be written as n minus 1. So if 1 here, then 2. So n minus 1, n minus 2, n minus 2, n minus 3. So on, and Jn minus 4. You can write like this. So this is reduction formula we obtained. If n is even, then this n minus even number will be obtained to 0. So j naught, so n minus 1, n minus 1, n minus 2, and so on up to j naught. And when n is odd, we obtain this is j1, and same, and left term before this one will be 3, 1 upon 3, not 1 upon 3, 1 less, it means 2 upon 3. So this is expansion we obtain for Jn. So we have to find what is J0 or J1. On this basis we can easily tell. So as Jn is given 0 to pi by 2 cos nx dx, if we put 0 here, then there is nothing. Cos raised to the power 0 is 1, so derivative is pi by 2. So we obtain pi by 2, and when this is 1, so finally we obtain sin x, and limit from 0 to pi by 2, this will be j1. So what is j1? Sin pi by 2, 1 minus 0. So this is 1, and this is pi by 2. It means that if n is even, then because containing pi, So if n is even, then irrational. So if n is even, then irrational. If n is odd, then rational. So we conclude these results, and now comes to the options. If n is even, if n is even, so first option Jn is rational for all n greater than equal to 2. So this is not true because n greater than 2 containing some odd and even terms. So we have for even terms Jn is rational. So this option is wrong, same as this option is wrong. And if n is odd, then Jn is rational. So particularly for n equal to 7, n equal to 7 is odd number, so Jn will be rational. So this option is true. So only option C is correct.